Imagine a football player standing on the field ready to make that perfect throw. The player calculates, adjusts his stance, and then with a swift motion, the football soars through the air in a beautiful arc before landing precisely where he intended. What just happened there is a classic example of projectile motion. Now, what exactly is projectile motion? It's a form of motion experienced by an object or particle that is thrown near the Earth's surface and moves along a curved path under the action of gravity only. The first formula in our discussion is the formula for the horizontal distance traveled by a projectile, also known as the range. The range, represented by the letter r, is calculated using the formula r equals 2 times the initial speed, denoted by u, times the sine of twice the launch angle, denoted by theta, all divided by the force of gravity, g. Next, we have the formula for the maximum height reached by a projectile. This is represented by the letter h. The maximum height is calculated using the formula h equals u squared times the sine squared of the launch angle, all divided by twice the force of gravity. The third formula is for the time of flight, denoted by t. This is the total time the projectile is in the air. The time of flight is calculated using the formula t equals 2 times the initial speed times the sine of the launch angle, all divided by the force of gravity. Finally, we have the formula for the velocity of the projectile at any given point. This is represented by the letter v. The velocity is calculated using the formula v equals the square root of u squared minus 2 times g times y, where y is the height at that point. In summary, we have 4 key formulas related to projectile motion. The range is calculated as 2 times the initial speed times the sine of twice the launch angle, all divided by gravity. The maximum height is calculated as the initial speed squared times the sine squared of the launch angle, all divided by twice the force of gravity. The time of flight is calculated as 2 times the initial speed times the sine of the launch angle, all divided by gravity. And finally, the velocity at any given point is calculated as the square root of the initial speed squared minus 2 times gravity times the height at that point. Remember, just like the football player on the field, it's all about understanding and applying these principles. With a bit of practice and a good grasp of these formulas, you too can predict and understand the beautiful arcs of projectile motion.